Properties of rational and irrational numbers. Our learning targets are: why is the sum or product of rational numbers rational? Why is the sum of a rational number and an irrational number irrational? Why is the sum or product of irrational numbers sometimes irrational? And why is the product of a non-zero rational number and an irrational number irrational? I wonder, is 1/2 plus the square root of 2 a rational number? Before we begin, we need to review rational and irrational numbers. Rational numbers are numbers that can be written as fractions a over b, where a and b are both integers and b cannot equal 0. Examples are included in the chart: -3, 5, and 0, and the square root of 9 are just a few. Irrational numbers are numbers that cannot be written as fractions a over b. The square root of 8 and a very common one, pi, are some examples of irrational numbers. So, based on the previous slide, 1/2 is a rational number and the square root of 2 is an irrational number. We basically want to figure out if the following is true. 1/2 plus the square root of 2 equals a rational number. If we subtract 1/2 from both sides, we would be rewriting it as the square root of 2 equals a rational number minus 1/2. That doesn't look right. Isn't the difference of two rational numbers also rational? How can an irrational number equal a rational number? I guess that must be false. The only other option is for it to be irrational. So, 1/2 plus the square root of 2 is irrational. What if we tried 2 plus the square root of 2? Well, we can say 2 plus the square root of 2 equals a rational number, and then subtract 2 from both sides, and we can rewrite it as the square root of 2 equaling a rational number minus 2. But that doesn't work either. The square root of 2 plus 2 has to be irrational. I'm starting to see a pattern here. Every time we have an irrational number plus a rational number equaling a rational number, we end up rewriting that as an irrational number equaling a rational number minus a rational number. You're right, and that ends up giving us something that doesn't make sense. The right-hand side is always rational, and that can't be equal to an irrational number. Well, I guess that can only mean one thing. Irrational numbers plus rational numbers cannot be rational numbers. So, the sum of an irrational number and a rational number must be irrational. Now let's find a pair of irrational numbers whose sum is rational, and find a pair of irrational numbers whose sum is irrational. The square root of 2 plus negative square root of 2 is 0. Here's two irrational numbers whose sum is rational. The square root of 2 plus the square root of 2 is 2 times the square root of 2. This is an example of two irrational numbers whose sum is irrational. What can we say about the product of two irrational numbers? The product of two irrational numbers can either be irrational or rational. For example, the square root of 2 times the square root of 2 is 2. That's two irrational numbers multiplied together to give you a rational number. However, the square root of 2 times the square root of 3 equals the square root of 6. That's two irrational numbers multiplied together to give you an irrational number. What about the square root of 2 times 1/2? Is that rational? No. The square root of 2 times 1/2 is an irrational number. This can be seen using reasoning similar to that used in the previous dialogue. If you rewrite the question as the square root of 2 times 1/2 equals a rational number, this can be rearranged to the square root of 2 equals a rational number times 2. Since the right-hand side is a rational number while the left-hand side is irrational, that gives you a contradiction. This means the assumption that the square root of 2 times 1/2 is rational must be false, and therefore the square root of 2 times 1/2 is an irrational number. In review, why is the sum or product of rational numbers rational? We already know that a rational number plus a rational number will be rational. 5 plus 1/2 equals 5 and 1/2. We already know that a rational number times a rational number will be a rational number. Example, 1/2 times 1/2 is 1/4. Why is the sum of a rational number and an irrational number irrational? As shown in the task, an irrational number cannot equal a rational number. Why is the sum or product of an irrational number sometimes irrational? If we add an irrational number to an irrational number, we can get an irrational answer. Pi plus pi equals 2 pi. But if we add an irrational number to an irrational number, we can get a rational number as well. The square root of 3 plus negative square root of 3 equals 0. If we multiply an irrational number by an irrational number, we can get an irrational number. The square root of 3 times the square root of 2 equals the square root of 6. Or we can multiply an irrational number times an irrational number and get a rational number. The square root of 3 times the square root of 3 equals 3. And last, why is the product of a non-zero rational number and an irrational number irrational? Remember, the square root of 2 times 1/2 is an irrational number. This can be seen using reasoning similar to how we did it in our dialogue. If you rewrite the question as the square root of 2 times 1/2 equals a rational number, you can rearrange it to be the square root of 2 equals a rational number times 2. Since the right-hand side is a rational number while the left-hand side is irrational, that gives you a contradiction. This means the assumption that the square root of 2 times 1/2 is rational must be false, and therefore the square root of 2 times 1/2 is an irrational number. This is a video that teaches properties of rational and irrational numbers.